Hello everyone, welcome to the class. Am I clearly audible and visible to everyone? Good evening, Dr. Sahu. Hello, Sakshi. Good evening, Zaheen. Hello, Arshia. Good evening, everyone. Somebody please affirm that we are live, and I'll just text in the group that we are live, and I would request everyone to join in quickly. So, hi everyone. For those who know me and for those who do not, I am Muskan Gumbar, and we are here completing this full-fledged course on CUET, PG, and GATE. And in today's class, we will be continuing with the steps of hypothesis testing, operationalization, and various types of sampling which are there. If you have any doubt from the previous class that we have had, please type it in, and then we will begin with today's class. Okay, let me read your doubts. Arshia is saying, ma'am, when you were explaining what is significance, that is a cutoff point to reject the null hypothesis when it is true. No, it would be the cutoff point to reject the null hypothesis when it is false, right? If you remember, we discussed this, that when null hypothesis, I'm so sorry. If you remember, we did this, that when null hypothesis is false, only then we will reject it, right? If null hypothesis is true, then obviously we will retain this. If we do not do that, then there are going to be error. If we are going to falsely reject a true null hypothesis, that is an error, right? So level of significance is nothing but it is a probability of what? When we talk about level of, significance, as it is associated with our type 1 error, which is false positive. So you can say that this level of significance basically represent the probability of rejecting our null hypothesis when it is true, which means it will showcase false positive. Correct, Arshia? Okay. Then, is that what you were trying to ask, Arshia? Because alpha is, signifying the type 1 error, hence it is the probability of rejecting. Dekho, Arshia, when we talk about this particular topic in general, right, we have read that there can be two type of error, type 1 error and type 2 error. Okay, type 1 error is associated with our level of significance, which is denoted by alpha. Type B is, dealing with the beta error, which is the error of power. Now, when I talk about type 1, we are saying that we give a cutoff point for our research, right? We decide alpha value beforehand, before we actually collect the data, collect the sample, etc. So we know that there are going to be this critical region which are signifying of the our alpha value. So for example, if it is a two-tailed hypothesis, then it will be 0.025, 0.025 on either of these sides, right? So if my null hypothesis and the value of null hypothesis is going to fall under these critical region, what I was doing, I was rejecting it, right? That was what we were doing. This is clear to you, Arshia? That is why I say keep always tell about the doubt in the group itself priorly, because I have not added that slide in today's class. I'll have to open the different PPT. But I am kind of understanding what you are trying to ask. You just tell me till this point it is clear to you that how we have this, probability density plotted in our curve, and we have these critical regions which are nothing but the alpha or the level of significance that we have been choosing, like that we have been choosing. Clear? Yes, no, something. Acha, wait, let me open that slide then. Just give me one moment. I'll just open that slide. This one. Now you tell me, Cha, what is the doubt? All right, ma'am, I actually understood everything that you taught. I have a doubt in that slide. The last point, wait, let me see the last point. Okay, the last point is saying the significance level is the probability of rejecting the null hypothesis when it is true. Why we are saying that? That we have this curve, we have these critical regions which are decided on the basis of the alpha value that we have selected. So what is this doing? This is the probability, no matter I am choosing 0.05 or I'm choosing 0.01, whatever I am choosing, right, as the alpha value, it is the probability that my null hypothesis can be rejected even when it is true, right? Because it is leading to rejection of null hypothesis no matter if it is true or if it is false. So that is why we are saying that it is talking about the probability of rejecting the null hypothesis when it is true, because it is associated with type 1 error, that it will show the false positive. Clear? So Arshia, please type in your doubt quickly, bachche. Arshia, we decide the level of significance on by our own. It depends upon the researcher, where like what is the cutoff point or what is the margin of error they would want to leave. On that basis, we decide the alpha value. Because why we reject our null hypothesis in critical region, because in this region we are saying that the values would be so high, right, that whatever whatever values are coming up, they are so in the extreme end of either of the tails, which means that there is no randomized random chance that they will fall in that region. That is why we are saying that if my values are coming out to be this extreme and they are falling under any of the critical region on either of these sides, okay, then it will show me that yes, there is actually an effect and there is no random chance that my result would be true. That is why we reject our null hypothesis in the critical region. Clear? Okay, if you still have any doubt in regard to this, Arshia, post it in the group and then maybe I'll take it up tomorrow. Clear? So, wait, let me change the slide again. Back to today's class. All right. Has the slide changed for everyone? Okay, wait. So first of all, I have brought few PYQs for you all, which are in regard to yesterday's class. I think I've brought like 4 or 5 PYQs. Please read the question carefully and try to answer. This question deals again with what we have just discussed in Arshiya's doubt. Please read the question carefully and try to answer. Wait, Ayushi, I'll just read your doubt. Ayushi Bacha, when we talk about measuring a particular variable, then yes, there can be a chance that there are various tools, various scales, various other measures which can be used to calculate a certain variable. Okay. But we have to pick on a standardized tool or a standardized procedure, etc. For example, if I want to see the effect of running on heartbeat, then there is going to be a tool which will be measuring a person's heartbeat and how much they have run. So we need to have certain standardized procedure that we take into consideration. Okay, and yes, the researcher decide the critical region on their own. Okay, how much error of margin do they want to leave? Right, everybody, please type in your answers quickly. All right, let's see the question. The question is asking significance level represents the probability of rejecting our null hypothesis when it is true. Correct, we have just explained all that in the first 5 minutes of our class. Moving ahead to the second question, please read the question carefully and try to answer. The region where we do not reject the null hypothesis will be known as what? All right, everyone, please type in your answers quickly. Very good, everyone. Yes, correct. The area, the region where we do not reject the null hypothesis is known as the acceptance region. Where we reject is known as the critical region, right? Or the rejection region. Both are the same one thing or the other. Chaliye. Moving ahead to third question, how do we calculate the statistical power of a test? Very simple, direct question. Please type in your answers directly, quickly. All right, everyone, very good. We calculate the power of our test by deducting the chances of committing type 2 error, which is represented by beta. Moving ahead to question number 4. Please read the question carefully and try to answer. All of you, please answer carefully. All right, everyone, let's read the question. The question is asking if a study concludes that a new therapy is ineffective, which means that null hypothesis will say that it is ineffective and alternate hypothesis will say that it is effective, right? So what is true? Our alternate hypothesis is true, which means null hypothesis is false, and we have still accepted, we have still retained this null hypothesis, which means it is the error of false negative, which is our type 2 error. Correct? Very good, everyone. Now the last MCQ for today. Please read the MCQ nicely and try to answer. All right, everyone, please type in your answers. All right, everyone, here in B will be the correct answer, not C, because this is a cutoff point, not an error margin, right? There it is allowing that this is the cutoff point, that after this our null hypothesis will be rejected and before this it will be accepted, right? And yes, it talks about how much chances of error are there, but we are not saying that there are a error margin of 5%. No, that is not a clear depiction. B is the more viable option here, which is saying that if we have selected our alpha as 0.05, it means that there are 5% chances of committing the type 1 error, right, which is rejecting the null hypothesis when it is true. Correct, everyone? Should we move ahead? Is it clear to you why B is the correct answer, not C? Again, D will not be correct. Alpha does not tell us about the power. Beta tell us about the power of our test. Right? Chaliye. Moving ahead to our class for today. So first of all, we will see the steps in hypothesis testing. Till now, what we have learned so far, we have learned that first of all, we set up our null hypothesis and our alternate hypothesis. Then we will specify the alpha level that we would like to have for our study. Right, then obviously we will, select the sampling method, collect the sample, calculate the result, etc. And it will give us the value. For example, I wanted to compare a sample with population, right? For example, I was, there was a patient who was there, okay, and I had to check their blood pressure. Right. So now for the null hypothesis, I would be saying that there will be no difference between the average blood pressure of the people and the blood pressure of the patient who was visiting me. And then the alternate hypothesis would be that yes, there would be a difference. I have set up my alpha value as maybe 0.05. Okay, then I would do what I would select the sample, which is my patient, then collect their data, etc. And at last compare the value of the blood pressure that I've gotten from the patient with the population's average, right? So if we are trying to compare sample with population, then we take either Z test or T test, right? Now I know that I will get a calculated Z value. In the last class, I remember there were some people who had a problem ki ma'am, how did we get to this value? How did we do that, etc. We will read about the formula of Z test, T test, etc. And after using that particular formulas, we can get a Z value which is listed here. So we have these statistical table for each of these tests. Okay. Now what happens is, when we look at these particular, what do we say, table, I know that the Z value, for example, I calculated a Z value of 1.1, okay, and my alpha level that I specified was 0.05. Now I will look at this table. Everybody, you tell me, this is the alpha value that we have set up, and this is the Z value that we calculated. Now all of you please tell me what will be my table value. Everyone, quickly, what will be my table value? No, Ayushi, you do not generally get graph assessment in CUET, PG or GATE, etc. exam. Max to max, you can be asked to calculate the power, that you can be given the beta value, and then you have to calculate the power of the test, 1 minus the beta value which will be given to you. Okay, but you will not be asked very difficult question. These will be there. What we have just discussed, like what we discussed on the basis of graph, etc., they are more relevant when we talk about the application of tests. So tests, you will see that there are more complex questions which will be asked in regard to that. Okay, now very good everyone, we were able to see this particular value. Which was it? It is this 0.8749, which is our table value or the P value that I have gotten. Clear till now what is happening? Now you need to understand the difference between the alpha and the P value. How did we get the P value? How did we get the alpha value? The alpha value was set up before the data analysis, before even the data was calculated, right? And when we talk about the P value, it will be calculated, it will be seen from the table after we are done with our data analysis. Correct? We know this is a fixed threshold that the researcher is deciding, and this is the calculated probability that we are getting after calculation and then looking at the table, etc. Okay, now how do we actually accept or reject a null hypothesis? We actually compare this P value with the Z value. Right, so this P value is actually the actual strength of evidence against my null hypothesis, right? So this P value, the table value that we have just gotten, 0.8 something, that was the strength of evidence against the null hypothesis, which means it is the strength at which the null hypothesis can be wrong, and our level of significance was nothing but the minimum risk that we were taking for our type 1 error, that I will accept my null hypothesis, I will reject my null hypothesis when it is true for 5% or 1%, etc. Now for the final decision, we have to compare these values. So my alpha value is 0.05 and the P value that I have taken is 0.8. Now whenever you have to accept or reject a null hypothesis, we need to take certain things into consideration. Now you tell me, this is the value that we were looking at. So if the P value is smaller or equal to our alpha value, then what do? We reject our null hypothesis. Okay? If this p-value is smaller or equal to my alpha value, then I will be doing what? I will be rejecting my null hypothesis, which mean that again the graph thing that we have read, which would signify that my critical, the values that I calculated were falling in the critical region. Hence, I am rejecting the null hypothesis. Now you look at this and tell me what we will do. We will accept or we will reject the null hypothesis. Okay. Till you just tell me that you are able to understand how do we get the p-value. You are able to understand that? How do we get the p-value, everyone? Yes, no, something. Yes? Very good, Arshia. From the table that we look. Now, this table is giving me my p-value or my tabulated value, right? Which is doing what? It is the evidence against my null hypothesis. Okay? It means the probability that my null hypothesis is false. Clear? For example, when we took this null hypothesis of BP and that the person or the patient will have BP similar to everybody averagely in the population, and my alternate hypothesis was saying that there will be a difference. So what I will be doing, what I was doing, I was comparing the sample. For example, my sample got a BP of around 80/60. And the normal BP value which is accepted is 120/80, right? So there is indeed a difference, right? Which means my alternate hypothesis is correct and I will accept that and reject the null hypothesis. Similarly, when we run these tests like G-test, T-test, any test, chi-square, etc., we need to do what? We need to look at the table value of these particular tests, which will give us the p-value, which is the evidence against my null hypothesis, right? So you tell me, this evidence is saying that 0.8, right? Which is what? Which is greater than that of my null hypothesis. You tell me this is the level of error that we accept. And this is the error which we are committing, for example. So our p-value should ideally be less than the alpha value. Yes or no? Our p-value should be ideally less than the alpha value. P-value is the evidence against our null hypothesis, and alpha value is that we will accept the, we will reject the null hypothesis even when it is true, the chance of error. So it should be less, which means that the evidence against the p-value is more than that of the alpha value. Hence, we will do what? What we will do here in this case, everyone? Is it clearer to you now that what is p-value? It is nothing but the evidence against the null hypothesis. Very good, Samiran. Very good. If the p-value that I am calculating, if it is more than that of my alpha value, then we will do what? We will be accepting the null hypothesis, which means p-value should be lesser or equal to my alpha value for us to reject the null hypothesis, which means the evidence that I am getting should be smaller or equal to the alpha value that I have set up, only then we will be able to reject our null hypothesis. Otherwise, it will be retained. Clear, everyone? If you still have any doubt anywhere, please let me know. Clear? Yes, no, something? This is clear to you all that the evidence should be smaller or equal to our alpha, only then we will reject the null hypothesis. Yes, no, something, quickly. Yes, Arshia. Yes, very good, Zaheen. We will accept the null hypothesis only when the p-value or the evidence against our null hypothesis is greater than that of alpha. Correct? So you need to first of all understand this, that level of significance is what you are setting. P-value is what we are obtaining after calculation and after looking at the table, etc. Okay? Then comes the nature. We know this is the threshold that we are setting. This is the calculated probability. This is what we have calculated. P-value is the strength of evidence against our or null hypothesis, which will tell us whether to accept or reject. And how we will know that how to reject or accept our null hypothesis? When we compare this alpha value with the p-value. If the p-value is smaller than or equal to my alpha value, then I will reject my null hypothesis. Or if my alpha value is bigger, if my alpha value is smaller, it means my p-value is bigger than that of my alpha value, then I will accept the null or retain the null hypothesis. Accept is the wrong word. We will retain the null hypothesis. You just tell me, till this point it is clear to everyone? Yes, Arshia. Batao. In the example that I have given, so what we are seeing here, we have the probability value. If the probability value or the p value that I am calculating, it is equal to or smaller than that of the value of the alpha that I have set up. If yes, that is the case, then we reject our null hypothesis. If that is not the case, then we accept our null hypothesis. If we reject our null hypothesis, then we have a chance of committing type 1 error. If we accept it, then we have a chance of committing type 2 error. That's about it. Clear, everyone? No, we will reject the null hypothesis. Acha, that one. Yes, we will accept the null hypothesis. Correct. In this, we will accept the null hypothesis. Why? Because my p-value is greater than that of my alpha value. Okay. Clear, everyone? Are we good to move ahead? Samiran is saying we always go through null. Null is retained or rejected, but that does not mean that alternate is retained or rejected. It is a matter of proving. Yes, Samiran. Correct. Clear, everyone? Should we move ahead? For those who are not clear with what we have just discussed, please rewatch this specific part of the class. Okay? Now we are moving towards the most easiest part of research and stats that is there. The difficult part is over for today. Okay? So what we have discussed so far, when we talk about hypothesis testing, we have seen that first of all, I will state my null hypothesis, alternate hypothesis, then I will set up my alpha value. Then I will actually, conduct sampling, collect the data, run the test, analyze the test, etc. And how I'm going to analyze the test? I will see the probability value, which is the evidence against my null hypothesis, right? So if my p-value is smaller or equal to the alpha, then we reject the null hypothesis. If not, then we retain the null hypothesis. Clear everyone? If you still have any doubt, please ask away, then we will move ahead further. ठीक है मैम, आपने कल बोला था कि this is just the start. I am getting scared because these topics are very confusing. Arshia, once you get the clarity, maybe it is the first time that you are reading these topics. When I understood this hypothesis and everything for the first time, it was very confusing, and it was kind of scary, because when we study psychology and when we took psychology, we were not having this inkling that we will have to read about all of these topics which have to do with stats and all of these research, etc. But yes, I am sure, Arshia, that if you will, read about them, revise them twice, thrice, more times, then it will get clearer to you, and it will seem like the most easiest topic to you, because in theory you have to remember a lot of things, but in research and stats it is simple, it is clear, no matter what research you are doing, no matter what you are studying, right? But still, the hypothesis, the way you state, the way you set up your level, the way you accept, reject, etc., it remains the same throughout, right? So it will not be change of information again and again. One time struggle hai, but then after that it is very easy journey. Okay, clear? Moving ahead to operational definition. Now we know that we have understood this in our step of research process also, that we always operationalize and we always define our variables, right? So operationalization is what? We are carefully determining the exact procedure, the operations that we are going to be using in my study. For example, if I am measuring the IQ of people in my study, then I will say that I am measuring the G factor of the intelligence, or I am measuring the analytical component or componential component or experiential or social intelligence, etc. So we need to directly, carefully mention the procedure that we will be using, the test that we will be using, what is basically intelligence for me. It is how I am measuring intelligence in my particular study, in my particular research, and that is what operationalization is. Clear? Clear everyone? What is operationalization? Should we move ahead? Moving ahead to our major topic for today, which is sampling. So we know that when I'm doing any research, right, no matter I am working on any research problem, for example, I want to see the effectiveness of a particular drug, right? Now I want this drug is applicable on maybe all the people who suffer from anxiety. Right, now I know the people who suffer from anxiety, or the population, or everybody who suffer from anxiety, they are going to be quite large, right? For example, there are going to be thousands, lakhs of people who suffer from anxiety. Do you think it will be possible for me to go and collect all of their data? Do you think that is possible? Everyone, do you think it is possible to collect our data from everybody who is maybe suffering from anxiety, or in all the population? For example, I want to see how young adults, what is the level of self-esteem of young adults in who belong to maybe generation Z. It is not possible, right? So what do? We do sampling. Sampling is what? We are going to take a representative sample. We are going to take a representative data set from my population. So for example, if I'm testing this drug of anxiety on people or everybody who is suffering from anxiety, so I will set up my representation. I will be like, okay, they should fulfill the DSM criteria of anxiety. They should have been suffering from anxiety for maybe more than 6 months, etc., etc. So because of the complications, because of the time consuming nature, because of the financial constraints of getting to understand a population or study the whole population, we look at a representative sample. We select a subset, we select a small data set from my population so that I can work upon them, so that I can test my study upon them, and then later on infer, later on conclude and make observation about my population. Clear everyone? What is sampling? Sampling is a statistical procedure that we conduct in order to study a small or few people or the few data set which are representative of the population. Always remember, if I am taking I want to study about all the people who are there, I want to study young adults. Now you tell me, if I only take males, do you think it is a representative sample of all the young adults? Yes, no, something. Do you think it is a representative sample for young adults, males, if I only take males for my study? No. Why? Because there can be other people. There are going to be females. There are going to be, people who associate with third gender, etc. Right? There are going to be gender neutral people also, gender fluid people also. So we need to take up a sample which is representative of my population. Very good, everyone. Now, moving ahead, there are various types, there are various types of sampling. We categorize both of them majorly into probability sampling and non-probability sampling. As the name suggests, probability, right? Probability basically means that there is a chance for everyone in the sample to get selected. Okay? And we can calculate that chance. Just know that there are going to be, everybody will have a chance to get selected, and that chances can be getting selected. For example, there is a bowl wherein there are, chits of 100 participants. So now I can calculate how much chance does each person have to get selected. And most of the probability sampling techniques are based on the principle of randomization. We believe that if we randomly select our data set, if we randomly pick up our sample, it will be more representative of my population, and there would be better generalization, better observation, better inferences that I can make about my data. Clear? Moving ahead to non-probability sampling. Non-probability sampling may, first of all, the chances of getting selected we will not be able to calculate. It will be based on non-randomization. For example, if you are a college student and for example you stay in hostel, so whoever used to live near your hostel room, you collected data from all of them. So that data is not random, and everybody did not have a chance to get selected in your data. Those who stayed near you, only those had the chance of getting selected. So this kind of sampling are majorly based on convenience or a specific criteria, etc. Okay, now let's elaborate upon various types of probability and non-probability sampling. So, probability sampling, first of all, we will be talking about simple random sampling, also known as fishbowl method of sampling. Now, in this particular type of sampling, everyone has an equal chance of getting selected. For example, if I want to see the level of maybe I want to see maybe opinion of class 3 students on maybe rhymes or maybe their teacher, etc. Okay, so what I will do, everybody who will be in class 3 has an equal chance of getting selected. So for example, if there are a total of 100 people in my population, so everybody will have an equal chance, which means it will be 1 by n. N here refers to the total number of people in population. Clear? So for example, if I have this chit bowl, so I have taken out the slips of all the 100 participants and I will just draw a slip. Right, so what does that mean? It means that all the 100 participants whose chits are in that fish bowl, all of them have an equal chance of getting selected, which can be calculated by 1 by. Clear, everyone? Yes, no, something. Clear? Yes, 1 by n is the formula for simple random sampling. Okay, chalo. Moving ahead. Now there can be two types of simple random sampling. Let me add one slide to elaborate upon that. All right. So now this simple random sampling can be of two types. It can either be with replacement and without replacement. Now, how with replacement or without replacement? Now, you tell me one thing. If, there is this fish bowl which is there. Okay? There are these 100 participants which are there. And if I take one slip out, then the total number of n will drop down to 99. And then if I take one more slip, then it will drop down to 98. Then I take one more slip, it will drop down to 97. That will happen. So in order to avoid that, what do? We put the chit back in this with replacement type. That we would like the total number of participants to be 100. Right? We would like. So what is there? The speciality of this with replacement. Total, which means the n remains same. We put the chit back, which means the data or the person that we have selected, we are putting them back in the lot. Now you tell me one thing. Don't you think it will increase the chances of selecting that particular chit one more time? For example, if there are for example, if you are playing Tambola, for example, right? We have numbers ranging from 1 to 100. And if I'm putting all of them again in the same bag, there are more chances that I will draw the same number one more time. There are, right? So herein what will happen? Ki selected sample can be reselected, which is not what we want, right? So that is one of the drawback or the limitation. Clear everyone what is with replacement? Because we want the total number, we want the n to remain the same. That is why we are putting the chit back. Clear? Should I move to without replacement? Okay. Now without replacement will basically be that the n will keep on reducing. For example, first of all, you had 100 participants, then next time you will be remained with 99 participants, then 98, etc. Hence, every time the chances of getting selected will change. For first time it was 1 by 100, then 1 by 99, then 1 by 98, etc. Right? So there is a better, this is better. Why? Because one person will be selected only one time, but the probability will keep on changing. And that is its limitation. You all just tell me if this, sampling, this type of sampling, simple random sampling, and this with replacement and without replacement is clear to all of you. Yes, Samir. It will be like n minus 1, then again n minus 1, then again n minus 1. Yes. In with replacement, actually, we do, this is one of the limitation of with replacement. For example, if I have this fish bowl and I have, put the chits of all the students who are there in the class, and I take one chit and call out the name of the person and then put the chit again back, then put again, then draw another chit, then draw another chit, etc. So what happened? There are chances that same student can be called out one more time in the chit, which is not what we want, right? Ideally. So that is one issue. Apart from that, that is well enough. Clear everyone? Should we move ahead to other type of sampling? Yes, no, something. Yes, Arshia, wait, let me see. Arshia is saying why change in probability is limitation. Because if you see that the chance of getting selected is getting increased in each time the person is drawn. Okay? For example, for the time when there were 100 participants, then the chance of getting selected was 0.001. Okay? But when only maybe 10 participants will be remaining, then it will be 0.1. Right? So the chances of getting selected will keep on increasing. That is why we are saying that equal chance is not there. Once a person is selected, the chance will keep on, increasing for each participant. Clear, Arshia? Why is that a limitation? Yes, no, something, everyone. Moving ahead to other type of sampling. Okay, we have systematic sampling. Systematic sampling again is a type of probability sampling wherein we can calculate the chances of a person getting selected. Here in every nth person will be selected. For example, I am saying that every second या फिर every third person will be selected. So what I'll be like, 1, 2, you are selected, 1, 2, you are selected, etc. and so. Okay, so herein every nth person is selected, but this type of sampling is suitable only for smaller population. Clear everyone? What is systematic sampling? Pretty easy, pretty short and simple. Chaliye. Let's move ahead to other types of probability sampling. We have stratified sampling. What is there in stratified sampling? In stratified sampling, we create stratas. What are the stratas or what are those stratum? Okay, so for example, if I want to study about, just give me a second. I want to study about a particular school and all the students who are there in that particular school. Now what I have done is I have maybe segregated these schools into various standards. Obviously, there is standard 1, standard 2, standard 3, 4, 5, etc. And there are multiple sections of each of these sections as well which are there. Okay, now understand one thing. When we talk about these stratas will be homogeneous within, which means that all the people who belong to the class 1, they will be similar in nature. Standard 2, within this standard 2 will be similar in nature. But these, two standards are different than each other. Okay? So these two standards are homogeneous within, but if we compare one stratum with another stratum, then obviously they will be homogeneous in nature. Clear everyone? Now how do we do sampling in this type? Okay? There are two ways in which I can actually collect sample. First is proportionate. Okay, so proportionate stratified sampling. Now what I will be doing here, for example, if grade 1 has 100 students, grade 2 has 50 students, grade 3 again has 50 students. So what I will be doing, I will be creating a ratio that, okay, 2:1:1. So, for every 2 participants which will be selected from grade 1, only 1 participant from grade 2 and 1 participant from grade 3 will be created, will be selected or will be drawn. So this is known as what? This is known as the proportionate stratified sampling. Okay, Arshia is saying that, ma'am, but some books I have read that this type is not probability. No, Arshia, this is a type of probability sampling, because even though they do not have equal chance, we are not saying that everybody will have an equal chance of getting selected. We are saying that we can calculate that chance. We can have a probability of how we are going to have, and everybody is having an equal chance. Why? There is 1/3. Every one person out of the 3 people will be getting selected. That is the level of probability which is there, right? Yes, Samiran, correct. In the updated books, it was clarified that this was a mistake. Okay. Now you tell me one thing. Can I say that I can calculate the number? I can calculate the probability of each person getting selected in each of these stratas also. So I can say that from grade 1 everybody has an equal chance of getting selected, so 1/k. Herein also 1/k2, 1/k3. and so on. This is what? This is proportionate sampling, but there is a limitation, there is a ratio, there is a quota that we have decided amongst us on the basis of the total population. So this will be representative of actual division in population. So for example, if there are maybe 1000 males and 990 females, so I will be saying that there will be 100:99 ka ratio between male and female. So now this is representative of the actual division of these stratas or these stratums in the population. This is the proportionate stratified sampling. Okay. Moving ahead to disproportionate stratified sampling. Just let me add one slide. Just a moment. All right. So when we talk about disproportionate stratified sampling, what are we saying? We are saying that, for example, there is grade 1, grade 2, grade 3. So I am, randomly deciding that, okay, I will take 50 students from each of these standard. Okay, so now there would be what? 50 divided by the total number of people in this strata, 50 divided by total number of people in this second strata, 50 divided by total number of these third strata. So I am not here taking into consideration the actual amount of people which are there in each of these strata. For example, in grade 1 there are 1000 students, in grade 2 there are 200, and grade 3 there are 100. So maybe this 50 are representing these grade 3 well or these grade 2 well, but these 50 are not the good representation of these 1000 people or the 1000 students who are there in grade 1. So hence there it can be misrepresented at times, because there are no actual ratio, or they are not maybe synonymous to the actual division in the group. ठीक है. Arshia saying, ma'am, 1/k वाली चीज नहीं समझ में. Arsha, just know one thing, bachcha. This k is referring to people in each stratum. So for example, if there are 1000 students in these each in this grade 1, then I can calculate the probability of all of these 1000 students getting selected by 1/k1. Okay, then 1/k2 for grade 2, 1/k3 for grade 3, etc. Make sense? So in disproportionate, what is happening? It might happen that the total number of percentage, for example, if I divide 50 by 1000, it will come out to be only what, like maybe 0 point something, right? Which is not a very good representation in the final sample that we are taking. That is why it is not as good as the proportionate stratified sampling. Now we will just do the last type of probability sampling, and we will carry forward with the non-probability sampling from tomorrow. Like in tomorrow's, tomorrow will be a holiday, I guess. Monday is going to be off for some time, till the time we actually complete our research unit. Chalo, let's look at it. So when I talk about cluster sampling is also known as area sampling. Okay? And this sampling is generally used for large geographic areas. So for example, if I want to study about all these states in Uttar Pradesh, right? I want to maybe collect data of all these cities in Uttar Pradesh. I want to collect data from, UP. So there are various cities in UP, right? There is maybe Agra, there is maybe Meerut, there are a lot of cities which are there in UP. So in order to make it easy for me, I will do what? I will select one or two full city. That okay, this is where I am going to select my data from. Okay, या फिर what I can do, I can select this one or two full city. This is known as first stage cluster sampling. And if still these data is very much for me, then I will move towards the second stage cluster, wherein I will, do random sampling from these two cities as well. That I will select few people from city 1, few from city 2, etc. Not all of them. So for example, I want to study about all the schools in, for example, Uttar Pradesh. So maybe what I will do, I will go and I will select the sample from one particular school from UP, which is basically telling me about the school students who are there. Right, but just know one thing, this cluster sample is collected from the naturally occurring data which is there. Okay, and these clusters can be heterogeneous within as well. So what will be the difference between the strata and cluster? Clusters are heterogeneous within, whereas these stratas are homogeneous within. Right, so we do these strata to improve precision, that we have, gathered one type of people or people who have one type of characteristic. We have set them into these various stratums, various groups which are there, right? And we are taking sample from each of these stratas. But in cluster, we have taken these heterogeneous clusters which are naturally occurring. Okay, and we can take either full cluster, which is the first stage cluster sampling, or we can even sample within the cluster, which is second stage cluster sampling. That's about the probability sampling. So we have discussed about these various aspects. We have discussed about various types of probability sampling. We have talked about simple random sampling with replacement, without replacement. We have talked about stratified sampling, wherein every nth person will be selected. We have we have talked about systematic sampling, wherein every nth person will be selected. We have talked about stratified sampling, disproportionate and proportionate sampling in stratified sampling, and we have at last talked about cluster sampling. I hope the difference between stratified sampling and cluster sampling is clear to all of you. If you still have any doubt anywhere, please let me know. I would explain that and then we will wrap our class for today. Clear? Thank you so much. If you like this class, you can give it a thumbs up. I'll see you all on Tuesday now. Bye-bye. Take care. And I don't know, I think less people knew about that we will be having class on these Saturday, Sunday. So I would want all of you to revise these two classes, the hypothesis class and this particular class that we have done today once again, so that you can revise and you can have better grasp over the concepts that we have done. They are pretty easy. It's just that you need to revise them once or twice or thrice, and you would have better knowledge or better grip on these topics. Thank you so much, everyone. Bye bye. Have a good night. Take care. See you all on Tuesday.